Okay, we're going to go over how to get MMMAudio running on a Mac. If you go to the MMMAudio documentation and getting started, you will see the directions for how to do this. So it says here, first thing to do is clone the repository. But if you don't have Python installed, that's actually what you want to do first. Probably the best way to install Python is with Homebrew. And you can install a specific version. It has to be above 3.12. So I would do this first. And now we'll get on with the directions here. So first thing to do is to clone the repository. So I'm going to go into the terminal, right? And by default, the terminal is in your root directory. So, you have your desktop documents folder, etc. in there. So I'm going to go into this dev directory, and I've got all this stuff that I've made, and I'm going to paste the git clone. And now MMMAudio should be in there. Great. So if I look for that directory, right, MMMAudio. So what I'm going to do is I'm going to open this folder with Visual Studio Code. So if I go into Visual Studio Code and I just drag this folder into Visual Studio Code, that's one way to open a folder. You want to trust the authors. And then you have the repository over here. So you can see there's the examples, the source code, the Python code. And what we're going to do is we're going to say new terminal. And when you open up a new terminal, it'll be in the folder. It'll be in the folder that you're in. So it'll be in this folder right here. That's why we're doing it in Visual Studio Code. So if we're in the terminal here, we need to go through the instructions. So first thing I want to do is create a virtual environment, right? So you can just copy and paste this stuff if you want. Now, it says right here, depending on your system setup, you may need to explicitly specify the Python version, and I actually think that's a good idea no matter what. So I'm going to type this, Python 3.13, Python 3.13, I should have just typed it, -m vonv. So if you run that, what it's going to do is it's going to make a virtual environment with Python 3.13. Then if you want to get into the virtual environment, you have to activate it. So activate, source vonv bin activate, right? And notice when you do that, you get this virtual environment right here. So now I am in the virtual environment, and that's where I want to be. So if I go back to the instructions here, we need to install a bunch of things with pip. Now you don't need all of these right away, but you might as well install them. These are the things that we use in different parts of the repository. So I'm going to run that. And these things will get installed. So NumPy and SciPy are like your math libraries in Python. librosa is an audio library. PyAuto GUI we use for the mouse. PyTorch is machine learning. Mido is the MIDI. Python OS, open sound control. RTMIDI is another MIDI library. Matplotlib is for plotting. And PySide6 is the Qt graphics library. So those are all really necessary. Okay, when that's done, we want to install Mojo. Now, Mojo, we specifically have it tied to version 25.6.1 right now. That'll change in the future, but you want to install that specific version. So now we're going to run that. And the last thing, so it's probably good that you have Homebrew installed, because the easiest way to install Port Audio and Hit API is with Homebrew. So you run these two installs, and then once those are installed system-wide, then you can use pip to install the bindings, the Python bindings. So basically, these are C libraries that get installed on the system, and then we need to do this to get them working in Python. So I'm just going to paste that there. and it installed them. Okay, so now our system should be ready to go. And everything's installed and ready to go. So the first thing you want to do is go into examples and try an example. So I'm going to try the many oscillators example. And if you notice with all of these files, there's a Python file and there's a Mojo file. So basically all programs have two files. The files don't have to have the same name, but some things do have to have the same name. So if I open up the many oscillators.py file, this is the Python code. It says from Python.Maudio import Maudio. So this is the main Python program that we're running, which is Maudio. And then we run the Maudio program. If you hover over here, these are the options that you have: block size, number of input channels, number of output channels, in device, out device. And it will use the default, which means it will use what your system is set to. And mine is set to my RME. But you can change that, so you can explicitly tell it to go out a different device. But if you have your system settings set to the device you want it to go out, you don't have to do that. So my block size is set to 128, and then in device is going to be default, out device is default, 2 channels in, 2 channels out. And the graph name is many oscillators. So this is important because many oscillators is this file, many oscillators.mojo. So this is the Mojo code. So Maudio is written in Python and Mojo. And if you open up this file there, at the top, we import the Maudio library. And then here we have stereo beating signs, which is a struct, and then a struct down below called many oscillators. So it's important that your Mojo file is called many oscillators, and then this struct is called many oscillators, because what the program will do is it will look into this file and it will look for a struct with the same name. So they have to have the same name. The other thing about this struct that has to be the case is you have to have a next function, and that next function has to have only self as the arguments. So you can't have more arguments other than self, because it's looking for, the program is designed to look for a struct with the same name as the file that has a next function. You can return any number of channels. This is returning a 2-channel output. So if I go into here, this should run. Oh, and the last thing is, package name examples. So if you look over here, we are in the examples folder. So if I'm running something in the examples folder, that's what the package name has to be. So when it compiles the program, it's going to look in the examples folder. If you look in the tests folder that is inside of the examples folder, so a Python file in here is looking for examples.tests, because that is the directory that it's in. So if I want to run this, this first line of code imports the Maudio package, and then this line of code compiles the graph. And when you first run a Python program in VS Code, after setting up that virtual environment, you need to tell it where Python is on your computer. So we need to go to command palette, view command palette, and say Python select interpreter. So if you just type select interpreter, it'll eventually, you can see Python select interpreter. And the one you want to pick is the virtual environment that is inside your directory. So these are versions of Python that are installed on my system. I don't want to use those. I want to use the one that we installed in the virtual environment. So venv bin Python. And that should make it work. So if I run these one at a time, that was cool. It's going to take a second to compile because it's compiled, that it has compiled, and then start audio. Okay, so this program has like messages that we can send, so we can change the number of oscillators to 2 or 14 or 300. It's actually 428 or 600. We can stop the audio. Great. So you don't have to run these lines separately. You can also run them as one instruction. And if you noticed, that was much faster at compiling because it didn't compile. It knew that the compiled file was correct, and it just ran it. So when you're making new programs, it's going to have to compile every time you change the code. But if you don't change the code, then it will work without having to compile. So it just runs the compiled file. And if you go into MMMAudio cache and you look in there, there is a file called Many Oscillators Bridge, which is the file that it compiled. So that's an executable inside the program. You don't have to think about that, but just know that this folder will fill up with a bunch of different executables of the different programs that you're compiling. Okay, let me just show a couple more things here. One is an example that uses the play button, or you can just run it in the terminal. So I'm going to do feedback delays GUI. So notice the file is called feedback delays GUI. These files, you can tell kind of what they are because it'll say something like import sys. It needs to run this line to be able to just run the file with the play button. So I'm going to run it with the play button, and it'll compile. Now this uses the Qt library, so the graphics engine that has like widgets, control widgets. Right, so that's how you run some of these different programs, where you can just press play, or you can just compile them in the terminal. So notice that whenever I stop a program, I close it. That's because if you have something open and running, the next file that you go to. So if I go to grains and I want to run this line of code, if the previous program was open down here, it'll try to run it in the same terminal. So this is just kind of how you interact with the program. You're kind of closing the terminal often. Great. So to show you one more thing, if you want to now I would definitely encourage you to explore all these examples. There's a lot of really good stuff here. So let's say you wanted to make your own program. A good idea would be to make your own folder here. If you look in the git ignore, there are two folders that are ignored, mine and user files. So if you make one of those, so I'm just going to make a new folder called user files. That's a good folder to use because then the Git won't track those files, basically. So if you're somebody who wants to it needs to then update your repository, it won't overwrite the files accidentally. You definitely don't want that. So now a good thing to do is maybe to copy the default graph. That's just basically those files are there so that you have something to copy, and put it in user files. Great. And so now a couple things I need to change here. So default graph is correct. It's still called default graph.mojo. And so you notice that all these, there's a lot of underlined red things here. This directory needs a file. and that file is, you can find it in, for instance, the examples folder. There's a file called __init__mojo, and that is an empty file. So I can also just copy that file if I want and place it in the user files directory. And now it should be able to find everything, and it does. So what this file does is it tells the compiler that this is a package that contains Mojo files. You don't need the Python file, but you do need the Mojo file. Okay, so we've copied the files. We've made the __init__mojo file, and then we now can run this graph. Notice this is called default graph. So when it looks for default graph, it's going to look at that if we change this here. So we move this to user files, right? And so now this is going to work. So that's just a simple program that has a sine wave oscillator because it's a sawtooth wave, and we're sending it random floats. So, if you wanted to change this to your own thing, so let's say we're going to call it my saw, right? My saw. Then in here, we need to make sure we change the default graph to my saw. And when we run it, we're not looking for a default graph, we're looking for my saw. So now this should run. Okay, so that's the summary on getting MMMAudio up and running.